Welcome to qnawire.
Okay, so this is the force diagram for the drum. Let's take a look at the moment about point O. Consider counterclockwise moment is positive, clockwise moment is negative, and this will give us FB times 125 millimeter minus capital M is equal to 0. So we have FB is equal to moments over 125 millimeter, which is equal to 35 Newton times meter over 0.125 meter, since 125 millimeter is equal to 0.125 meter, and this will give us the friction at point B is equal to 280 Newton. So since we trying to prevent the drum from rotating, therefore the friction at point B, we consider the friction at point B is the static friction. So, and then this is the force diagram for the brake bar. So now let's apply the force equilibrium for the brake bar. So we have a net force along the y direction is equal to NB minus P. So we have force P is equal to NB. Since we consider the friction at point B is static friction, therefore we have NB is equal to FB over mu s, which is equal to 280 Newton over 0.4, and this is equal to 700 Newton. Therefore, I have a force P is equal to 700 Newton. So force P equal to 700 Newton is the smallest value for the force P. And then let's take a look at the force equation for the drums. So the green letters here are the force equation for the drums. So we can still apply the force equilibrium for the drums, since our goal is to prevent the drum from rotating. So along the x direction, we have FB minus OX is equal to 0. Let me go to the graph here. So as you can tell, FB is pointing to the right and OX is pointing to the left. And this will give us FB is positive, OX is negative, since we consider the right direction is positive. And this will give us OX is equal to FB, which is equal to 280 Newton. So the horizontal components of reaction at pin O is equal to 280 Newton. So along the y direction, we have OY minus W minus NB is equal to 0. So we have OY is equal to W plus NB. Since OY is pointing upward, W and NB is pointing downward, and we consider upward direction is positive. And this will give us OY is also equal to mg plus mb, which is equal to 25 kilograms times 9.8 meter per second squared plus 700 Newton. And this will give us the vertical components of reaction at pin O is equal to 945 Newton. And these are the answers for this question.